Today we're going to talk about Kubernetes security, kind of 101 talk, right? Just an introduction, and it's like even if you're new to Kubernetes or never used Kubernetes before, you're going to understand a little bit more because I'm going to talk about what it is and how it works and all the little pieces, right? But yeah, the idea is half of the presentation kind of we understand Kubernetes and the minimal, the small pieces. Like Rafael said, it's a complex system, right? And it's very hard to understand. It took me a while to understand as well, and even today I don't consider myself like an expert in Kubernetes, but we'll see. Yeah, so let's start. Let's see here. Okay. Okay, so yeah, oops. Basically, yeah, just a little bit about myself. My name is Magno Logan. Yeah, there's a typo there, but it's fine. I work as an information security specialist and senior threat researcher at Trend Micro. I'm also part of the cloud and container security research team and the CNCF tag security used to be called SIG security. Now it's tag security team, right? Which the CNCF means the Cloud Native Computing Foundation. As I said, I don't consider myself a Kubernetes security expert yet, but I'm getting there, hopefully. And as I said, it's a complex topic and there's a lot of stuff to learn, right? And also have a personal blog at katanasec.com where I try to publish articles at least once a month. But also there is all my contact information there, my social media, Twitter, GitHub, and LinkedIn. And also all the previous talks that I have given before since 2011, right? So 10 years of presentations, slides, or videos, if they have been recorded, they are all there for you to see and take a look. Okay, yeah. So what is the agenda for today, right? So first we're going to talk about what is Kubernetes, right? I don't know if you're familiar with it, right? If you have used before, if you're using an organization, it's a very famous container orchestration platform, and it's being used by many different organizations. So yeah, so we're going to understand the architecture of Kubernetes, what are the all different components and how they talk to each other, understanding a little bit about the control plane and the main components of the control plane, the API server, the etcd. We're going to talk about role-based access control, right, which is the main form of control in Kubernetes, and that's very similar to other web applications as well. We're going to talk about the worker nodes, which are the nodes that run your applications itself, and you're talking about kubelet and pods and understand what is a pod, right? And in later, then we're going to talk about network policies, pod security policy, which is being deprecated, and audit logs, right? So some features and some best practice for you to implement in your cluster to increase and improve the security of your clusters. Okay, before we move on, I just want to mention that since I started studying about Kubernetes since the beginning of last year and also focusing my research on Kubernetes security a year ago, I created this list of links and information and books that help me understand more about Kubernetes. And then I decided to create a GitHub with that list, with all that information that I gathered all these months, right? So I shared that and I created this awesome Kubernetes security list. It's on GitHub, and I can share the link later on chat if Raf doesn't see it. Okay, good, it's there. Yeah. So it almost has 1,000 stars already on GitHub. A lot of people enjoyed it, and I think it's one of the honestly, I'm a bit biased to say, but I think it's one of the best lists for learning Kubernetes, and it has a focus on Kubernetes security. But of course, to understand Kubernetes security, you need to understand how Kubernetes works. So there is some links and stuff, documentation to learn how Kubernetes works as well. So I highly recommend that you check that out. Okay, so what is Kubernetes, right? When everybody's talking about that and orchestrating containers and like moving that to the cloud and okay, how does that work, right? Why is Kubernetes so popular, right? So first and foremost, Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications, right? What does that mean, right? Or like, can you explain to me like I'm 5? Okay, let's do that, right? So first and foremost, Kubernetes was created by Google in 2014, and it's developed in Golang, right? And it was created in a way that right after Docker was released in 2013, right? So yeah, you have your containers with Docker, and it's interesting that you can run them, but at the time you didn't have a way to manage those containers like in a scaled way, right? When you have hundreds of servers and thousands of containers, it's really hard for you to manage them only using Docker, right? You had to create a bunch of scripts and automate some stuff, but it was still very hard, right? So that's when Google came out with the idea of creating and releasing Kubernetes. It's based on 2 internal projects from Google called Borg and Omega, right? So you're gonna hear about a lot of those projects when they talk about Kubernetes as well, but those are internal projects and they are closed source from Google. So Google has been using containers and orchestrating containers in a long time internally, but they decided to create a new version of their own project to release that to the public, right? So once that was released in 2014, Google also donated this project to the CNCF, and we're going to see what the CNCF is, but basically it's the Cloud Native Computing Foundation, which is a sub foundation of the Linux Foundation, right? And takes care of many different cloud native projects. Okay, so why also like one fun fact here, right? Kubernetes is also written on the abbreviation form. It's written on KAS, KAS, and that only means that right in between the K and S of Kubernetes there is 8 letters, and so that's why there's KAS, right? Another fun fact is the Kubernetes comes from Greek, and it means helmsman, right? Helmsman is that person that kind of drives the ship, right? It can be the captain, but sometimes it's another person that's just driving the helm, right? The helm of the ship. That's why the symbol of Kubernetes is a helm. That's what they call it. Okay. So yeah, before even you begin your Kubernetes journey, I think the most important thing that you should ask yourself is, why Kubernetes, right? Do I really need that? Do I really want to go that route, right? Am I scaled enough that I would really use all the benefits and of Kubernetes, right? So that's one of the main things on why Kubernetes, and that's why I brought this comic from Dilbert, because it's like, yeah, you can't say just like funny names and buzzwords and new technologies and that's magic, right? It's not like that. You need to have the need for that. You need to have the resources, right? Budget for it, because it's usually these new technologies, only a few people know about it. And so they're going to be expensive for you to pay them, right? To hire them. And so that's one of the things that you need to keep in mind when you're deciding your organization to move to Kubernetes, right? It might not be the best choice for you. So just keep that in mind. And as I said, it's a very complex system, and you need people that understand it, right? So that you can run it properly. So yeah, what's the CNCF that I talked about earlier, right? Basically, the CNCF is the Cloud Native Computing Foundation that takes care. It's a non-profit, not-for-profit organization that takes care of cloud native projects, right? They provide funding and support and also technical expertise on many different areas, including security for those projects, right? And those are only some of them, like a few of them that have been that have graduated, but there's a lot more projects. If you check that link on the slides there, the l.cncf.io, which is the landscape of the CNCF, you're gonna see hundreds of projects there that are part of the foundation, right? And some of them, they have like different stages of maturity, right? And some of them are still in a sandbox, and some of them are still beginning their journey in the CNCF. Those are the projects that are usually, those ones in the slides here are usually graduated. They're more mature, they have a bigger community, and they're more stable for you to use in production, right? And like, hey, but what is cloud native, right? Have you, I probably seen this terminology before, and maybe you don't understand. Like, cloud native, is it because it runs in the cloud? No, that's not the only reason, right? You can have cloud native applications running on bare metal and running on premises, and they still are called cloud native, right? But they're usually applications designed to work on cloud environments. And on cloud environments, it's like they are they have the declarative APIs, they can be automated, right? They can be they run immutable infrastructure. So those kind of characteristics, as you can see from the left, these are kind of the characteristics from cloud native applications. Like, they're scalable, they're dynamic, resilient, loosely coupled, right? So microservices, manageable, observable, and automated, right? So those are some of the characteristics of cloud native applications. And on the right side here, we have some examples of cloud native applications, like such as containers, service meshes, microservices, and other things. There is a specific definition of cloud native on the CNCF GitHub page, and that's the link there on the slide. And you can check that out. I know it's a complex kind of concept, but that's what they mean. Like, when you're talking about cloud native, it doesn't mean, oh, because it just runs in the cloud, right? It means that it's designed to run on cloud services. And by the what I mean by cloud services, it can be like on premises, right? It can be a VMware or any other vendor cloud service as well, and it can run on premises, right? So it doesn't mean that you need to run on major cloud providers such as AWS or Azure or Google, right? So it doesn't mean that. Okay, moving on. Yeah, if you have any questions, feel free to put them on the chat there, and I'm happy to like stop and answer them, no problem. Forgot to mention that. Okay, so this is the most important slide that I think I'm going to cover today. So let's try to focus here. Building some suspenses. So yeah, basically here you have the most basic Kubernetes architecture, right? Kubernetes has at least two major components. You have the control plane, which sometimes is called master node, but they're trying to avoid that for using control plane because of inclusive language, right? So let's call it control plane. But we also have the worker nodes, right? Worker nodes are the nodes that run your application, and control plane are the main components of your Kubernetes cluster and handles everything, basically everything on the cluster. So here, let's take a look on the right side, on the left side here on the control plane. You can see that there is a main component there in the middle that's called the Kube API server, right? Where pretty much all the communication goes through the API server there. And the Kube API server is just a regular REST API server. If you've seen, if you worked with REST APIs before, you know how that works. And it receives all the communications from all different components and direct them for the right to the right location, right? On the top, on the bottom right corner there is the kube scheduler, and the kube scheduler is the one that schedules the pods and the containers to run on your worker nodes, right? On your cluster. On the bottom left side here, we have the etcd, and the etcd here is the one, the key value store of your cluster, right? It's where all the configuration of your cluster is stored. And one key thing here that's kind of differentiates Kubernetes from other applications is that Kubernetes has something that's called the desired state, right? So the desired state means that Kubernetes, like, it doesn't matter how Kubernetes gets it done, right? But if I ask Kubernetes, if I ask my cluster, oh, I want this Nginx application running, this container running, like, I don't care how you do it, just do it, right? So Kubernetes, once that's like, I send that command to a Kubernetes cluster, they save that on etcd, and what's going to happen is Kubernetes is going to check, and with the other components here that we're going to talk about, like the controller manager, they're going to check, okay, I see there is a configuration of an etcd a container there is a configuration of Nginx container that's saved here on the etcd database, right? Okay, is that container running on my cluster already, right? And so they're gonna check, and they're gonna ask the worker nodes, okay, do you have a Nginx container running? If not, okay, they're gonna say, no, I don't have it, right? I don't have anything. Okay, so now they checked all the worker nodes, and there was no Nginx container running. Now they're gonna say, okay, to achieve the desired state, right, we need to reflect what's on etcd should be reflected on my cluster, right? So whatever configuration that I wanted, that I saved on etcd, should be the same, at least, like they try to make it the same of what's in my cluster. So they're gonna tell the kube scheduler to create a container on one of those worker nodes to an Nginx container, right? So that it reflects the desired state of the Kubernetes cluster. If I need one, I need to have one, right? If I increase that, I can easily increase that to, oh, I need 3 replicas of Nginx, then they're gonna create 3 replicas. And that's what's very interesting of Kubernetes, that scalability and that concept of desired state that can be tricky for people to understand. Like Kubernetes doesn't care, they take care of it, right? So it doesn't matter of what you ask for Kubernetes, they're gonna try to deploy that on your cluster and reflect that whatever is on that CD, reflect that on your worker nodes. So yeah, moving on the top left side here, the kube controller manager. And I'm going to make a joke here, but I hope there are no managers in this call. But if there are, understand that this is a joke, right? So like any manager, the controller doesn't do much, right? They don't do much by themselves. That's what I meant to say. They have other controllers, other components, sub-components of the controller manager that really do the controlling of the Kubernetes cluster, right? So you have the pod controller, you have the service controller, and many other Kubernetes objects, right? So, and the manager only manages them, right? So yeah, that's the trick here. They each controller, they check, okay, do I have the right number of pods? Is the service working properly, right? So it's kind of doing this constant verification of your cluster. If you ever watch a Kubernetes cluster API request, you can see that it's very noisy, right? Because it's always talking to each other. It's always communicating, and it's always sending requests to make sure that whatever state is on etcd is reflected on your cluster, right? So that's very interesting. And you also have the cloud controller manager on the top right side there of the control plane, which deals with components that are usually not part of your cluster, but you can use, especially when you're using cloud providers. So let's say you need a disk volume or a load balancer, and you're using AWS. And so the cloud controller manager takes care of that communication with the AWS API to deploy a load balancer and connect that to your cluster, right? Basically for that reason. Okay. Let's go to the right side now, talking about the worker nodes, right? The worker nodes here, I have 3 worker nodes, and they have 3 main components. They have the kubelet, which is the daemon that really receives the communication from the kube scheduler and asks the container runtime engine to start the container running on that node, right? And if, like, I'm saying node here, but basically node can be a VM, bare metal server or whatever, right? So when I say node, think about EC2 instances or a VM machine. Also, you have the kube proxy, and the kube proxy handles all the communication inside your cluster, but also outside communications as well. And it basically handles IP tables, rules to do that, right? So we're not gonna go into that. And the last one, like the computer, the kind of the computer here is the container. It represents the container runtime engine, right? So the container runtime engine, which by default it was Docker, and they're probably, I'm not sure if they're probably changing that. I know that there was some kind of miscommunication around that. When they mentioned that Docker was being deprecated by Kubernetes, and everyone thought that their Docker containers wouldn't run on Kubernetes anymore, and that's not true. With the runtime engine, right? It can be Docker by default. Right now, I think it's still Docker, but it can be other container runtime engines such as Containerd or Cryo or Podman, right? You can choose and you can replace. Pretty much every component here in this diagram can be replaced by something else. And there are alternatives for that. So there are alternatives for kube proxy, for API server, and everything. Okay, what happens if the control plane goes down? Okay, are these control pieces usually running in a single server? So yeah, it depends on how you deploy a cluster, right? So if you deploy in unmanaged way, as we say, okay, you deploy at least two components, the control plane and the worker nodes, and you handle the Kubernetes cluster yourself, then if one of these goes down, like if the whole control plane goes down, the whole server goes down, then yeah, the control plane goes down. So that's why maybe you need a high availability control plane. You need to have at least two running, right? But if it's just one of the components, right, which they run as a pod, as a container inside the Kubernetes cluster, they just spin up, they just deploy another container, right? So if the kube API stops running, they just restart and deploy another container and should be back running again. But if it's the whole VM or the whole server, then probably, yes, you're gonna have a problem there, and it's probably going to stop working. And that's one of the benefits of using the managed services of Kubernetes, right? So every major cloud provider have their own managed service, right? So you have EKS for AWS, AKS for Azure, and you have GKE for Google, right? And many others, right? And what happens is on those managed services, you don't need to worry about the control plane, right? The control plane is provided for you by your cloud provider, and usually is high availability, right? They provide the API endpoint of the kube API server, and you don't need to worry about the security and anything related to the control plane component. So that's one of the benefits of using a managed services, but some of them there are costs, right? So some of them you pay for that. So you need to consider that when choosing a managed service. Okay, yeah. With the container runtime engine, as I said, it can be Docker or other runtime engines. It doesn't mean like there is a whole blog post written on the Kubernetes website talking about all the misconception of the Docker being deprecated and how that's not the case. I won't go into that here today, but if we have more time at the end, I can talk more about it. Okay, let's move on here. So yeah, Kubernetes has a lot of objects, right? And I've been talking about some of them already, right? You have your cluster, which is your whole the whole component of your Kubernetes there, together your control plane and your worker nodes, and you have nodes, right? So usually the control plane used to be called master node, right? And now the worker nodes used to be called minions, and now they're worker nodes. So basically a node is an instance, a server that can be either to run the main components of your cluster or run your own applications, right? And what's interesting here is that Kubernetes uses Kubernetes to run Kubernetes, right? It's like a kubeception, right? An inception of Kubernetes because they run their main components inside the cluster. Another thing to look for in this diagram, right? You have a pod, and a pod is the smallest unit of Kubernetes, right? You can have one or more containers in a pod. So what happens is it's basically an abstract representation of containers, right? You can't deploy just a container in Kubernetes. You have to deploy a pod. There are many other objects in Kubernetes, like deployments, like daemon sets, replica sets, and all of them are API objects, and they usually have a specific function, right? So here on this next slide, right, you have many different objects and many more, and you can even create your own objects, right? So each of them have a specific functions. For example, with job, job is a Kubernetes object that it's a container that runs only once, right? You deploy it, it runs, and it's done. You have cron job, which is a container that runs according like the cron tab, like from Linux, right? Same way, same principle, and it can run. You decide if it runs once an hour, once a day, or once a week, or whatever you want, right? And there are many different others here. One of the objects that it's important for security, for you to understand about it, right, is the secret. So the secret object you can be used to usually to store a secret information, right, sensitive information. But one thing with Kubernetes is that the secrets of Kubernetes is not very secret, right? The way that Kubernetes stores the secret on etcd, which is also not encrypted by default, and we're going to see it later. The way that stores secret on etcd is on encoded on base 64, right? And if you know, base 64 is easily decoded, right? And you can retrieve that value really quickly, right? So when storing secrets in Kubernetes, you can use maybe a third-party solution like a vault, HashiCorp Vault, or the own AWS secrets manager system, or you can try to encrypt your etcd, and you need to configure that because that's not done by default, so that you can store your secrets in a safe way. This is just a representation of the Kubernetes objects here. Like they usually YAML files, right? And they have the API version, the kind of the object is one of those names here, and you have data there. Okay, moving on. Okay, good. I have at least a basic understanding of how Kubernetes works now, but how do I talk to my cluster, right? If my cluster is not running on my machine, how do I talk to it on AWS or whatever it is, right? So yeah, just like Docker, they have the Docker CLI. For Kubernetes, you have the kubectl, which is also known as kubecontrol or kubectl, right? There is no consensus around the name. Each one can use their own preference, but I like to call kubectl. So the kubectl is a CLI tool that allows you to control your Kubernetes cluster, right? And for you to do that, you need a config file, a kubeconfig file that's usually stored on your home directory inside the .kube folder, right? And it's very similar to the Docker CLI for Docker containers. So if you use Docker before, it's going to be easier for you to start using the kubectl commands. Even the syntax is similar and everything, right? So they did that in a way that if people were transitioning from Docker to Kubernetes, they wouldn't have a hard, like a steep learning curve to learn about the syntax and all the commands, right? So I'll pause here for a minute and see if there are any questions, because now we're going to go into more on the security and the best practices side of the talk. Yeah, basically, yeah, kubectl is only a wrapper for interacting with API, similar to the Docker CLI, which is also a wrapper, right? Everything that you use on the kubectl or the Docker CLI, it becomes an API request, right? Which goes to the API server, right? So on that config file that you have to have and save on your machine to talk to your cluster, there is all the information about the API server URL, the certificates and the tokens that you need to connect to your cluster, right? But yeah, basically, if you check, like if you audit all the API requests on your Kubernetes cluster, you can see that's pretty much just HTTP API requests via HTTP or HTTPS, however you configure it, right? Yeah, that's right. Okay. So one of the things that we talk about when it comes to security of your Kubernetes cluster is you need, one of the basic things that you need to monitor is file integrity monitoring, right? There are a bunch of files and a bunch of permissions and ownership that are required on those files for your Kubernetes cluster to run, right? And those are taken from the CIS Kubernetes benchmark, this table here, which is basically a benchmark telling you the best practice of setting up and securing your Kubernetes cluster, right? So this set of ownerships and permissions, you need to monitor those, because if something changes here, then it means that someone can be messing on your cluster, and it can be your control plane or your worker nodes can be compromised, and there is something suspicious going on, right? So yeah, these are the default values of them. I'm not sure if that has changed, but pretty much if you monitor any changes on those ownership and permissions here, and if something changes, then you should definitely take a look at it, right? And that's the main files for the control plane itself. I have another slide for talking about the files in the worker nodes. Okay, good. Another thing that you need to worry on your cluster is the namespaces, right? So what is a namespace, right? Basically, a namespace is a logical separation between projects on your cluster, right? So you can have a namespace for your dev environment, for your QA environment in your prod, or you can have a namespace for your developer team 1, developer team 2, and so forth, right? And that's fine. It's like think about namespace as folders on your Kubernetes cluster, right? It's a logical separation. There is no specific or security boundaries between those namespaces unless you apply some RBAC, right? So role-based access control. So here are the default namespaces that it comes when you install the cluster, right? You have the default one, the kube node lease and kube public. But what I want to highlight here is the kube system namespace, right? So all the components that we talked about on the Kubernetes architecture earlier, all the components on the left side that were part of the control plane, if you have an unmanaged cluster, they're going to be inside that kube system namespace, right? So whoever has access to the namespace has access to the main components of your cluster. So you need to be very careful, because by default, there is no separation or no segregation between one pod in the default namespace talking to a pod in the kube system namespace, right? Unless you apply some access controls, right? So be very careful with that. Another thing that you need to worry about on your Kubernetes cluster is the API server, right? We talk about the Kube API server. It's one of the main components of your control plane, and you don't want that exposed to the internet usually, right? Usually you should have that restricted, because if you have that exposed, attackers are probably going to find it, and they're going to try to exploit your cluster some way or somehow, right? Basically, here is just an example of a curl request on a specific IP address of my API server. So on unmanaged Kubernetes clusters, the API server runs by default on port 6443, and on managed services like EKS, it runs on port 443, right? So here I just made a curl request, and you can see from the response, which is a JSON response, you can see very clearly that's not like any other web application response, right? And you can see right away that there is an API there, and this sort of response, it's very very specific to Kubernetes, right? So I know that there is a cluster running on that IP address and on that port. Even though I got a 403, right, a forbidden error, I know that there is a Kubernetes cluster there. And so that's basically what attackers are doing in the wild, right? They're mapping, they're scanning the internet for specific ports such as 6443 and looking for exposed API servers, right? You can find that even like on free tools such as like showdom.io, where you can search for specific Kubernetes clusters that are exposed on the internet. And there are some things that you can do to protect yourself, right? So one of the things that Kubernetes has is the RBAC, or the role-based access control, that I'm going to talk more about it on the next slide. And that kind of protects someone from compromising one pod on your cluster to affect your whole cluster, right? There are specific settings that you can apply to your Kubernetes API server, and that's also talked about on the CIS Kubernetes benchmark. If you have access to your control plane, right, on an unmanaged cluster, then you can just log into that cluster and type some of these commands here to see what configurations are enabled on your API server or not, right? But if you're running a managed Kubernetes cluster, then you don't have access to that, right? You don't have a shell access to your control plane. Okay, so role-based access control, right? The name is big, and it might be scary, but it's not. It's just like regular web applications that we used before, right? Like role-based access control is the control, the access control based on roles, right? Roles or profiles or however you want to call it, right? And just like many web applications, they already work like that, right? You have like a regular user, you have a manager, or you have an editor or writer, and then you have like the admin or root of the web application, right? The difference here is basically the RBAC of Kubernetes allows you to configure who can access what in your cluster, right? And it's enabled by default on the latest Kubernetes version. The difference here that I wanted to say is that Kubernetes doesn't have users, right? If you've seen the list of API objects that I showed before, we didn't have any users, right? So how does you access your Kubernetes cluster, right? They leave that for you to manage with other solutions like identity provider, right? It can be through OAuth and OpenID Connect. It can be any other way, right? Kubernetes only has the only object that you can create on Kubernetes are service accounts, and those are usually placed inside the pods to manage them and to give them the ability to talk to the API server. Okay, so how do I work with RBAC, right? How do I use the role-based access control? So there's basically 4 objects that are created, that can be created when you use RBAC, right? You have role and role binding, right? The top one there. Role means, okay, a set of permissions that I can give to someone or a service account for them to use the cluster, right? So those permissions can be, okay, list pods, get secrets, right? So it can be, it's usually a verb and an object, right? So list, get, and delete or create or something like that. And an object can be pods, can be services, can be secrets. It doesn't matter, right? You can create those permissions, and you create that on a YAML file, and that's the type of a role object. Then you have the role binding, right? So basically what the role binding is going to do, it's going to bind, right? It's going to connect the list of users or people that you want to access your cluster to the permissions that you need to have, they need to have actually. The difference here is that the role the permissions that are given in a row only applies to a specific namespace, right? So they are more restrictive. So if I want to give my users permissions only to create pods and leave secrets in a specific namespace, right? I should use rows, right? But there's also two other objects here that RBAC provides for Kubernetes for you to apply permissions on your cluster. And that is the cluster row and cluster row binding, right? And the only difference between those and to the other ones are that their permissions are larger, right? They're more permissive. And in a way that the cluster row, whatever permissions I give to a user via a cluster row, it's going to apply for the whole cluster, right? It's not specific to a namespace. It's for the whole cluster. So those are more permissive. So be very careful when using those. And that's one of the main complex things of Kubernetes, right? RBAC can be very complicated as well. If Kubernetes is not complicated enough, RBAC can get very tricky very fast, right? So if you have multiple users or multiple teams accessing your cluster, and if you have like multiple clusters as well, that can get very tricky very fast. So be very aware of that, because most of the issues with Kubernetes clusters, it's usually because too much permissions were given to a specific user, to a specific service account, and either that account got compromised or the user got mad or something, right? And they decided to do something wrong. So be very aware of that. Another thing that you need to worry about, right, is just like the database is the heart of any web application, right? So is the etcd for Kubernetes cluster, right? etcd is the main data storage location for your cluster, right? It means that all your cluster objects are saved here. I already mentioned that before. And we've seen over 2,600 etcd servers exposed on Shodan earlier this year, right? So probably there is more if you search today again for the port which etcd exposes, right? There is also an API for etcd which shouldn't be exposed as well, but we found that earlier in Shodan. Let me see a question here. Is there a native or third-party way to visualize this row? Yes, there is a native way to visualize the rows. There is something called the command called kubectl of the authentication, and can I, right? Of can I, and you can check which permissions do you have, or if you can do something, right? Can I get secrets? And based on your permissions, it's going to tell you, oh yeah, yes you can, or no you cannot. It basically answers yes or no, right? So you can do that natively with kubectl, but there are some third-party tools and plugins with Kubernetes that shows your whole RBAC structure, and it can point you to specific rows that might be too permissive and might cause any kind of security issues in your cluster, right? So there is a bunch of third-party tools that are open source and available on GitHub. I can provide some links later. Okay. So one of the things is with the etcd, the encryption in transit is done by default, right? Luckily, okay, that's good. So all the communication between the etcd and the API server is encrypted, right? It's usually by default. It sets a certificate file and a key file when you install the cluster, and that's good. Okay, but the encryption at rest, right, as I mentioned before on the etcd, it's not by default, right? By default, everything that's stored on etcd is stored in plain text, right? If you want to encrypt your etcd, then you need to create an object called an encryption configuration object and tell exactly to etcd what exactly do you want to encrypt. Do you want to encrypt everything? Do you want to encrypt only secrets or secrets and config maps? It's up to you, right? But that's not done by default, right? Okay. So let's talk about network policies, right? If the etcd didn't scare you enough, let's talk about network policies. And something that happens in the Kubernetes cluster that's very scary, at least from a security perspective, is that by default, all the pods can communicate with any other pod in the cluster, right? So if I have one pod running in one specific namespace and there is no network policy, I can talk with everyone. So it's just like a flat network. Imagine organizations today having flat networks in their environments, right? That's very a very scary thing to do. So for you to change that and avoid that from happening, you need to create network policies, right? And network policies in Kubernetes is a way for you to have kind of a network segregation inside your cluster, right? So some questions that you should ask yourself is like, does the front end pod really need to talk to the database pod, right? So usually you have like a front end, a back end, and a database, right? So the most simple way of the 3-layer application or MVC, right? No, the front end shouldn't talk directly to the database. It should talk with the back end, and then the back end talks to the database, right? So you can create a network policy to restrict any communication, because if one of those pods, especially the front end that's exposed to the internet, if it gets compromised, right, you don't allow much, you restrict the ability of the attacker to do any kind of lateral movement and move into your other pods and maybe even escape the pod, right? Escape the container and get access to your Kubernetes node, right? Another thing that you need to worry about here, right? You need to question yourself as well is, what if an attacker can access the pods on the kube system namespace? Remember that we said that kube system namespace has the main pods of your control plane, right? So if they can access that, right? If I have direct access to an etcd, I can just tell the etcd to save some objects there, right? Let's say, oh, save on etcd a privileged pod running my malicious Docker image, right? And Kubernetes is going to see that and it's going to look, oh, there is this new component here on etcd and it's not created on my cluster. Let's create it, right? And so Kubernetes is going to download that malicious image and install that on my cluster. And now the attacker has even more access because that malicious image is running as root, it's privileged, right? And that helps the attacker even to break out of the container and of the cluster itself, right? So we've seen some instances of that as well. And another thing that you need to worry about here is, once an attacker compromises a pod, if you're running on a cloud provider, right, you probably heard about the instance metadata API, right, where you can make API requests to your instance to this instance metadata and get sensitive information such as the access key and the secret key that instance is using, right, if there is one attached to the instance. So even on the pod itself, if I compromise only one pod and I'm not on the node yet, I can query that instance metadata of that instance, right? So if you don't protect that, from the pod itself, I can get your the credentials, the access key, and the secret key of that instance, and maybe even access something outside of the cluster itself. And what we've seen in the wild is the attackers have compromised a misconfigured environment that we deployed, and they deployed new instances on our cloud environment. Of course, it was a honeypot, but it was a controlled environment, but they deployed new instances to mine cryptocurrencies, right? And it took them less than 24 hours for that to happen, right? We deployed our honeypot and we didn't publicize anywhere. It's just because the URL was public by default. That's what happens on EKS. And they found that URL probably scanning the internet. They saw that there was a web application running there, and that web application was with a vulnerability. They exploit the vulnerability, they got access inside the cluster, and basically they did the rest, right? And so they deployed like big instances to mine cryptocurrencies, usually Monero cryptocurrencies. Okay, on EKS itself, they don't have, actually, let me back up a little bit. on to deploy network policies, you need to have a proper CNI, a container networking interface that supports network policies, right? So there's many different CNIs that you can use. You have Calico, you have Flannel, you have Cilium, you have Weave, right? So there's different ones. On AWS, the AWS CNI doesn't support network policies, right? So what they did was they came up with a way for you to use the security groups, which are usually used for EC2 instances. Now you can apply those security groups for your cluster, right? So you can create rules in between your pods to via the security groups. So that's, I think, was launched late last year. Let me see one more question here. Well, yeah, service mesh, it allows, it's like another layer of abstraction that you can use for, you can use network policies with service meshes as well, but service meshes are usually like proxy inside your cluster, and you can add like some security features like MTLS, like multi TLS. You can add some SSL inspection and all the stuff. It handles the certificates for you. But yeah, I'm not gonna go deep dive into service mesh here, but we can talk more about it later. So one of the common ones are Envoy proxy, and you have Istio and Linkerd as well. The Linkerd just graduated from the CNCF. And also there's some CNIs that can work as service mesh. So I just watched the presentation yesterday about Cilium, which is another CNI, and they can work as a service mesh as well. So it might not be necessary for you to use a service mesh. Sometimes it can add a lot of complexity to your cluster, even more complexity if you don't have enough, right? So yeah. Okay, so just moving on with the worker nodes here. Same thing, right? File integrity, there are specific files that you need to watch for. If there are any changes in ownership and permissions here, yeah, just be aware of it, right? And monitor that for suspicious activity. On the kubelet itself, right? I already said that kubelet is an agent that runs on each node of your cluster, even on the master node, right? So I know that the diagram that I showed doesn't have the kubelet and the kube proxy running on the control plane, right? Even on the official diagram of Kubernetes, they don't have that on the official documentation. But there is a proxy, a kube proxy, and a kubelet running on the control plane, right? Because how you're going to start the main components as containers, as pods on your cluster, right? So you need that as well, but it's usually because they don't want you running your own applications on the control plane, and by default, Kubernetes has a setting that only allows you to deploy your own applications on worker nodes, right? So the kubelet makes sure that all containers are running in a pod, right? And the main security settings here is restrict the kubelet permissions and rotate the kubelet certificates, right? And there are some attackers leveraging the kubelet. The kubelet also has an API, and we published a blog earlier this year talking about how attackers in the wild are compromising networks. And from the inside the network is that they are scanning for Kubernetes clusters and then compromising those clusters via the kubelet API. So I can post a link for that later too. On the pods itself, right? I know that we're almost out of time, but yeah, I'm wrapping up here. On the pod itself, like you need to worry about the resources, right? It's just like regular containers. You need to worry about CPU and memory. You can also apply a security context with some features as well. There is some examples here, right? And other security features for the pods, you can use the Linux kernel security features. Some of them that are recommended are seccomp, epArmor, and SC Linux, right? I'm not gonna go in deep dive into that, but you can enable that with a policy on your pod as well. Okay. So yeah, there was something called pod security policies, which was a way for you to apply some security settings for your whole cluster, right? but that got deprecated. That got deprecated in the latest version, I think, or yeah, 120 or 121, which is the latest version. And the Kubernetes 6 security team designed a new pod security that they're working on it and should be deployed in the next version of 2 or 2, right? So what this pod security policy was basically a policy that you could apply to your whole cluster and say, okay, I'm only allowing pods that are not running as privileged, that are not running as root, and they have like read-only root file system as true and all that stuff. So you could create that policy and apply that to your cluster, right? But yeah, that's being deprecated. There are alternatives to that. If you heard about policy as code, there are some tools that can do that for you. OPA, which is Open Policy Agent. There is a version of OPA called Gatekeeper that works for Kubernetes. And there is also another tool called Kyverno, which also allows you to deploy your own policies as code, as YAML files. And you can tell, okay, if this pod has a vulnerability, I'm not allowing it to be deployed on my cluster, right? Another thing that you need to worry about Kubernetes on your cluster is the audit logs, right? So audit logs are very important for security, but also for troubleshooting, right? But audit logs are not enabled by default, right? So it's highly recommended that you enable them for security and troubleshooting. Basically, to enable those audit logs, you need two things. You need a log path where you're going to save that log, and a policy file. What are you going to save, right? And you can set up those, set those up on your kube API server config file. Basically, right, some examples here of your log policy, right? You can have 4 levels of policy, right? None doesn't log anything. You can have metadata, which only logs metadata information. You can have the request, only logs request information, request and response, logs request and response information, right? Basically that. On EKS itself, it's very simple to enable that. Right? You can go to your console, and on the control plane section of your EKS, there is an option there for logging, and you can enable many different logins for the audit, the API server, the authenticator, there are many different ones. Just be aware that those, once you enable them, they are saved on your CloudWatch logs, right? And you can, if you want, you can ship them to like a SIEM solution. Like you can save them to an S3 and ship them to an Elk Stash or Splunk or however, whatever you like to do with them, right? But audit logs are very important to have, and they are very they're used to detect some malicious activities on your cluster. Yeah, to wrap up, I hope this session was interesting for you, right? And if you have any questions, I'll be available for chatting here or anytime via my social media, Twitter or LinkedIn. I'm always available to talk more about Kubernetes, but I just want to remind you about the basics, right? And that's something that even if you don't do anything that I said before, remember those 4 things, right? These 4 things are: update your Kubernetes environment version early and often, right? So Kubernetes releases versions very, at least 4, or now I think it's 3 times a year, right? So they reduce the number of times to release new versions, major versions, right? So so be aware of that and update your cluster, because usually when there's an update, there is some fixes for security vulnerabilities. Don't use your cluster admin for don't use the cluster admin for your daily work, right? Treat it like root, right? So once you create the cluster, you have the permissions of cluster admin. Don't use that. Create another user or another service account for you, and you use that instead, because if someone compromises the cluster admin, they can do anything on your cluster. If you can, use managed services, right? Such as AKS, EKS, and GKE. As I said before, those managed services, they take care of the control plane for you. They take care of the security of the control plane, the availability, right? So you don't need to worry about the etcd and the API server and the scheduler and controller manager, all that stuff. It's all taken care for you. You only need to worry about running your own applications, right? And also, if you have time, check out the CIS Benchmarks document. It's a big document, has a lot of pages, but it's very detailed, and it gives information about how you should run your clusters in the most recommended, the most secure way. And it shows also how to verify, right? Okay, this is the best setting for you to run your cluster. Okay, this is how you check if this setting is enabled or not, right? And if it's not enabled, this is how you enable it, right? So every recommendation has kind of like 3 steps, right? The recommendation itself, how to check if that's enabled for you, and how to change that on to be enabled, right? So something like that. And that's why it's very detailed, very descriptive document, but it's very highly recommended, because it has been written by cloud native security professionals and people that are involved with Kubernetes and cloud native for a while, and they know what they're doing. Just 2 more things before I wrap up. There's 2. It was released this year, the MITRE attack for containers, right? So I don't know if you heard about the MITRE attack framework. I won't go into details here, but it is a framework for you to map what attackers are doing in the wild on specific environments, right? And we didn't have that before for containers one. We had for cloud, for Linux, Windows. And so we worked with the MITRE team to release this framework earlier this year. In April was the official version, right? And it has many different techniques that attackers are using in the wild to compromise those environments. And I say it's not just for containers, it's for Kubernetes as well. Some of those techniques are very specific to orchestrated environments, right? Such as Kubernetes, or others such as Nomad or Apache Mesos or Docker Swarm, but mostly Kubernetes, right? And there is another version that was released by Microsoft, right? They released one last year in April, and now with the update of the MITRE framework, they release an updated version, but it's not an official MITRE matrix. So be careful not to confuse both of those matrices, because one is from Microsoft based on what they've seen on Azure alone, and there is another one from MITRE that many other organizations collaborated with them and provided data on their research and on their honeypots to create this matrix, right? Okay, so that's all I had for today. These are the references, and I can share the slides with you, no problem, and I'm open for any questions.